Auzubillahiminash-shaytanir-rajeem. Bismillahir-rahmanir-rahim. Dear students, Assalamu alaikum. I am Dr. Azhar Ali, Assistant Professor, Electrical Engineering Department, Sarhad University, Peshawar. Dear student, this is the first video lecture of week 4th for the course Applied Mathematics 1. Today, in this first video lecture of week 4th, we are going to learn about limits. Now, first of all, I would like to tell you about the definition of limits and some laws for limits. Let f be a function defined on some open interval that contains the number a except possibly at a itself. We say that the limit of the function f of x as x approaches a is L, and we write limit x tends to a for the function f of x is equal to L. If for every number epsilon greater than 0 there is a corresponding number delta greater than 0 such that f of x minus L absolute will be less than epsilon, where whenever absolute x minus a greater than 0 or less than delta. Now, some laws for limits. If L, M, C and K are real numbers and limit x tends to a for the function f of x is equal to L and limit x tends to a for the function g of x is equal to m, then the first law for the limits, limit x tends to a for the constant c is equal to c. It means that the limit of a constant real number is that constant. And law number 2, limit x tends to a for the polynomial p of x is equal to p of a, where p of x is any polynomial. It means that the limit value of a polynomial is the function value at that point. Now, law number 3, limit x tends to a, c limit x tends to a for the function f of x is equal to c limit x tends to a f of x. It means that the limit of the product of a constant and a function equals the constant times the limit of the function. And law number 4, limit x tends to a f of x plus minus g of x is equal to limit x tends to a f of x plus minus limit x tends to a g of x. It means that the limit of the sum or difference of two functions equals the sum or difference of the limit of the functions. And law number 5, limit x tends to a f of x dot g of x is equal to limit x tends to a f of x dot limit x tends to a g of x. It means that the limit of the product of two functions is the product of the limits of the functions. And law number 6, limit x tends to a f of x divided by g of x is equal to limit x tends to a f of x divided by limit x tends to a g of x. It means that the limit of the quotient is the quotient of the limits of the numerator and the denominator if the limit of the denominator is not 0. And law number 7, limit x tends to a f of x power n is equal to limit x tends to a f of x whole power n, provided this is defined. It means that the limit of a function raised to a power equals the limit of the function raised to the power, provided the math makes sense. Dear students, these law means that how to apply the limit when a constant and function are multiplied, how to apply a limit when two functions or sum are in difference form, how to apply a limit for the product of two functions, how to multiply the limit for the quotient of two functions, and how to apply a limit when a function f of x whole power n. So now we are going to discuss all these laws of limit by using some problems. You see over here, this is the first problem. To evaluate the limit x tends to 1 into x square plus 2x plus 4. Limit x tends to 1 for the function x square plus 2x plus 4. Now applying the limit law, because you see over here these three terms are in the form of sum. So applying the limit for the first term, then for the second term, and then for the third term. Limit x tends to 1 for x square plus limit x tends to 1 2x plus limit x tends to 1 4. Now you see over here there a constant term and a function are in the multiplied form. So applying the limit on x, now limit x tends to 1 for x square. So putting x is equal to 1, you see over here, and putting x is equal to 1 in this term, and 4 is as it is. So 1 square 1, 2 1 the 2 plus 4, so this is equal to 7. Now again another problem, limit, evaluate the limit x tends to minus 2 x cube minus 2x square plus 4x plus 8. So limit x tends to minus 2 for the function x cube minus 2x square plus 4x plus 8. Applying the limit x tends to minus 2 for x cube, for 2x square, for 4x, and for 8. Now limit x tends to minus 2 x cube, putting x is equal to minus 2 in this term. Now putting x is equal to minus 2 in this term, and putting x is equal to minus 2 in this term, and 8 is as it is, because 8 is the constant term and limit for the x. So we cannot put x is equal to minus 2 in this term because 8 is a constant term. So minus 2 power 3 is equal to minus 8, minus 2 power 2 4, 4 to the minus 8, multiplied 4 with the minus 2 we obtain minus 8, and 2 for the 8, and this 8 is as it is. Now minus 8 minus 8 minus 16, and plus 8 plus 8 plus 16, minus 16 plus 16 is equal to 0. So another problem, to evaluate the limit t tends to 6 8 into t minus 5 into t minus 7. So dear student, you see over here, this is the law of limit for the product of two functions. Here two functions are in multiplied form. Now applying the limit for this function and applying the limit for this function. You see over here in the previous slides that this is the law of limit. You see over here this law. Limit x tends to a f of x dot g of x. So applying the limit for f of x and applying the limit for g of x. Now applying this law number 5 for this question, for this problem, you see over here limit t tends to 6 for the function t minus 5, 8 is the constant term, and limit x t tends to 6 for the t minus 7. Now putting t is equal to 6 in this function and t is equal to 6 in this function, you see over here limit t tends to 6 for t. So putting t is equal to 6, 5 is as it is, and putting t is equal to 6 in this term, 6 minus 7. Now 8 multiplied 1 multiplied minus 8, we obtain minus 8. Now another problem for the limit, to evaluate the limit y tends to 2 y plus 2 divided by y square plus 5y plus 6. Now this is the previous law for the quotient when two functions are in divide form. You see over here in this slide, this is law number 6. When two functions are in the divide form, then applying the limit to the numerator functions and apply the limit to the denominator function. If the limit of the denominator is not 0, because we know that any non-zero term divided by 0 is equal to infinity. So if the limit of the function g does not equal to 0, then implying the limit for the numerator and implying the limit for the denominator, and then simplify, you will obtain the result. Like you see over here, these two functions are in the quotient form. Y plus 2 divided by y square plus 5 y plus 6. So using the law, applying the limit for the y plus 2 and applying the limit for the denominator y square plus 5 y plus 6. So you see over here, limit y tends to 2 y plus limit y tends to 2. This 2 is the constant term, so 2 will be as it is, and putting y is equal to 2 at this term, and divide by putting y is equal to 2 in this term, putting y is equal to 2 in this term, and putting y is equal to 2, but we cannot put y is equal to 2 in this term because this is the constant term. Now you see over here, after putting y is equal to 2 plus 2 divided by 2 square plus 5.2 plus 6, 2 plus 2 4, and 2 to the 4, 2 5 the 10 plus 6, 6 plus 10 16, 16 plus 4 20, 4 by 20 mean 1 over 5. Now another problem, to evaluate the limit z tends to 0, 2z minus 8 whole power 1 over 3. Dear students, you see over here, this problem is related to this law number 7. You see over here, first of all, put the limit for the function and then take the power of the result. You see over here, the limit of the function raised to a power equals to the limit of the function raised to the power, provided the math makes sense. So using this law, first of all, put the limit for the function and then take the power of the result. Like you see over here, limit z tends to 0, 2z minus 8 whole power 1 over 3. So first of all, applying the limit, don't take first the power of 2z minus 8 power 1 over 3. First of all, put the limit for the base. Like you see over here, 2z minus 8 is the base. So first of all, put the limit in this space and then take the power of the result. After evaluating the limit, take the power of 1 over 3. Don't apply this power before applying the limit. So first of all, applying the limit, z tends to 0, 2z minus 8, putting z is equal to 0 in this term. You see over here, z is equal to 0 in this term, z minus 8. This is the limit for this term, but we cannot put the limit z equal to 0 in this term because this is the constant term. So this constant term 8 is as it is, and the limit of z is equal to 0, we obtain 0 in this term. Now minus 8 power 1 over 3 mean we can write minus 8 minus 2 whole power 3, and the whole power is 1 over 3. So 3 and 3 cancel, we obtain minus 2. So dear students, you see over here in these some problems how to apply the limit for the product of constant in a function, how to apply the limit when two functions are in the form of sum or difference, and how to apply the limit when two functions are in the product form, how to apply the limit when two functions are in the quotient form. Now we are going to discuss some undefined limits which we can define. To define undefined limits, this is actually the undefined limits, but we can define this undefined limits. How to define this 0 by 0 undefined form of the limit? For example, to evaluate the limit x tends to minus 5 for the function x square plus 3x minus 10 divided by x plus 5. If we put the value of the limit in the function, so it gives the result as an indeterminate form, mean undefined form. Like you see over here, if you put x is equal to minus 5 square mean 25 plus 3 5 the 15 minus 15 plus 25 minus 15 plus 10 minus 10 is equal to 0. And if we put x is equal to minus in the denominator, minus 5 plus 5 again will be equal to 0. So this is actually the undefined form. Now we can define this undefined form by using factorization First of all, simplify this expression: x square plus 5x minus 2x minus 10 divided by x plus 5. By factorization, by sum and product, we can factorize this expression x square plus 3x minus 10. We can write x square plus 5x minus 2x minus 10. 5 minus 2 gave this plus 3, and 5 multiplied minus 2 gave us minus 10. First of all, multiplied this first coefficient and this last term. 1 multiplied minus 10, we obtain minus 10. And now choose their two numbers under the conditions. From the adding their two numbers, we obtain plus 3, and by multiplying their two numbers, we obtain minus 10. Dear students, I want to tell you again, by factorization by sum and product. For the factorization by sum and product, first of all, we multiplied this first coefficient with this numbers, like you see over here. 1 multiplied minus 10, we obtained minus 10. Now choose two numbers under the conditions. By adding their two numbers, we obtained plus 3, and by multiplying their two numbers, we obtained minus 10. So you see over here, 5 minus 2, we obtained plus 3, and 5 multiplied minus 2, we obtained minus 10. So 5 and minus 2 are the two numbers. By adding these two numbers, we obtain plus 3, and by multiplying these two numbers, we obtain minus 10. So this is called factorization by sum and product. Now we can write this plus 3 as 5x minus 2x. So x square plus 5 minus 2x minus 10 divided by x plus 5. Now taking common from these two terms, x square plus 5x, x in these two terms, x is common, x into x plus 5, and taking common minus 2 from these two terms, minus 2 into x plus 5 divided by x plus 5. Now you see over here, these two factors are same. When these two factors are same, then factorization by sum and product is correct. These two numbers will be correct, 5 minus 5 and minus 2. When we add 5 and minus 2, we obtain plus 3, and when we multiplied these two numbers, 5 and minus 2, we obtain minus 10. So the factorization is now correct. Now taking common from these two terms, x plus 5, taking common x plus 5, we obtain x plus 5 into x minus 2 divided by x plus 5. Now x plus 5 and x plus 5, these two terms cancel. Now applying the limit x tends to minus 5 for the function x minus 2, putting x is equal to minus 5 and this term, we obtain minus 5 minus 2 is equal to minus 7. Now another problem for the undefined limit. To evaluate the limit x tends to minus 1 under root x square plus 8 minus 3 divided by x plus 1. So dear students, if we put the value of the limit, so it gives the result as an indeterminate form. Limit x tends to minus 1 under root x square plus 8 minus 3 divided by x plus 1. So if we put x is equal to minus 1, you see over here, first of all, applying the law of limit for the quotient of two functions. First of all, applying the limit to the numerator and then apply the limit to the denominator. You see over here, putting x is equal to minus 1, minus 1 square plus 1 plus 1 plus 8, 9. Under root 9 is equal to 3, and 3 minus 3 is equal to 0. And in the denominator, you see over here, putting x is equal to minus 1, minus 1 plus 1 is equal to 0. So this is the 0 by 0 form. Now to define this undefined limit, we use here the conjugate, dividing, multiplying by the conjugate of this term, under root x square plus 8 minus 3. The conjugate of this term is under root x square plus 8 plus 3. Now dividing, multiplying this expression by x under root x square plus 8 plus 3. You see over here, limit x tends to minus 1 under root x square plus 8 minus 3 divided by x plus 1. Multiplying by the conjugate under root x square plus 8 plus 3 and divide by the conjugate under root x square plus 8 plus 3. Now multiplying these two terms, x under root x square plus 8 minus 3 multiplied under root x square plus 8 plus 3. By using the formula a minus b into a plus b, we obtain a square minus b square. So dear students, you see over here, this is actually the a term, this is a term, a term. So this is a term, a square, and this is the b term. Now a square, you see over here, this is actually the a square term, a square term. This is full a term, so a square minus b square. Now under root and 2 cancel, we obtain here in the next slide, you see over here, under root x square plus 8 whole square minus 3 whole square divide by, now multiplying these two terms, multiplying this expression with this expressions, we obtain x square plus 1 into under root x square plus 8 plus 3. So you see over here, now applying the formula a minus b into a plus b is equal to a square minus b square. Now this is a square minus b square, x square plus 8 minus 9 divided by x plus 1 into under root x square plus 8 plus 3. So x square minus 1 divided by x plus 1 into under root x square plus 8 plus 3. Now you see over here, this is again the formula a square minus b square. We can write a plus b into a minus b. So x plus 1 into x minus 1 divided by x plus 1 into under root x square plus 8 plus 3. Now x plus 1 and x plus 1, these two terms cancel. You see over here, these two terms will be cancelled. X plus 1 cancel. Now we obtain limit x tends to minus 1, x minus 1 divided by under root x square plus 8 plus 3. Now applying the law of limit for the quotient of two functions, for the division of two functions. Here two functions are in the divide form. Now applying the limit to the numerator and applying the limit to the denominator. So putting x is equal to minus 1 for the x minus 1 and putting x is equal to minus 1 for the function under root x square plus 8 plus 3. Now minus 1 and in the denominator putting x is equal to minus 1. Minus 1 square mean 1 plus 8 under root plus 3. Minus 1 minus 2 divided by 9 under root mean 3. 3 plus 3 is equal to 6 and minus 2 by 6 gave minus 1 over 3. So dear students, you see over here in this lecture, the conclusion of this lecture, how to apply the limit for the functions. You see over here there are 7 laws. Law number 1, how to apply a limit for the constant, how to apply the limit for a polynomial, how to apply the limit for the product of a function and constant, how to multiply the limit for the sum or difference of two functions, how to multiply the limit for the product of two functions, and how to multiply the limit for the quotient of, for the division of two functions. So dear students, in this problem you see over here, this is the sum of functions x square plus 2x plus 4. Now how to apply the limit for this? Applied the limit for x square, applied the limit for 2x, and we cannot put the limit x is equal to 1 in this term because this is the constant term. Constant term will be as it is. And you see over here in this law number 7, how to apply the limit for the power of a function. First of all, put the limit in the function and then take the power of the evaluated result. After evaluating the limit, then taking the power. So dear students, sometime we obtain undefined limit. We obtain the 0 by 0 undefined limit. We can define the undefined limit, 0 by 0 undefined limit. How to define the 0 by 0 undefined limit? In some problem we can use the factorization. So first of all, simplify the given functions, then we can define the 0 by 0 undefined limit. So to define the undefined limit, we simplify the function. by taking common, by taking factorization, by taking the conjugate. So for the factorization, if we use the factorization by sum and product, for the factorization of sum and product, first of all choose two number under the conditions that by adding their two number we obtain this term, and by multiplying their two numbers we obtain the result of the multiplication of the first coefficient and this last term. So first of all multiplied the first coefficient and the last terms, like you see over here, 1 multiplied minus 10 is equal to minus 10. Like you see over here in this slides how to factorize by sum and product. You see over here, first of all multiplied the first coefficient and the last term. You see over here multiplied 1 with this 10. So multiplied 1 minus 10, we get minus 10. So we get minus 10. Now choose two numbers under the condition. Choose two number under the condition that by adding their two numbers we can obtain this result. In this problem we obtain plus 3. And choose two numbers by adding the numbers we obtain this plus 3, and by multiplying the numbers we obtain minus 10. Like you see over here in this problem, 5 and 5 multiplied minus 2. 5 multiplied minus 2 we obtain minus 10. 5 multiplied minus 2 we obtain minus 10, and 5 minus 2, 5 plus minus 2 we obtain plus 3. 5 plus minus 2 we obtain this plus 3. So for the factorization by sum and product, first of all multiplied the first coefficient and the last term. Like you see over here in this problem we obtain minus 10. Now choose two numbers under the conditions that by adding their two numbers we obtain this term, and by multiplying their two numbers we obtain minus 10. Like in this problem minus 10. I want to tell you again, for the factorization by sum and product, first of all multiplied this first coefficient and this last term. Like you see in this problem, 1 minus 10 is equal to minus 10. Now choose two numbers under the conditions that by multiplying their two numbers we obtain this result, and by adding their two numbers we obtain this result. So dear student, this is the process for the factorization by sum and product, and sometime we define the 0 by 0 form by taking the conjugate. So dear student, this is the conclusion of this first video lecture. Inshallah, in the second video lecture for fourth number week, we discuss the continuity of a function. Now this is the end of this segment. Thank you. Allah Hafiz.